Okay, in this video we're going to review how to solve systems of linear equations in MATLAB. Okay, so we know MATLAB is a very powerful program. It's very useful. And one of its main strengths is that it's very easy to define and perform operations on matrices. Right? And what you'll learn after using MATLAB for a while is that, if you can think of your problem in terms of matrices, then MATLAB provides a lot of tools to help you solve your problem. And one key aspect of this, one very, very large aspect of this, is solving systems of linear equations. And so a system of linear equations is defined as a set of unknown variables and a set of algebraic equations that define the relationship between these variables. And so, I think you might have seen a system like this, right? So we have three unknown variables here. So we have x1, x2, x3. Okay, and we have three equations here that define the relationship between these variables. Okay, and so if you have an equal number of unknown variables as equations, then you can solve that system for the values of those unknown variables. Okay, and so here we have three unknowns, x1, x2, x3, and we have three equations, and so this is one that can be solved. Okay, and so the key to this is that these equations must be linear equations, and so that's kind of why this is called system of linear equations. And what that means basically is that all the unknown variables have to appear in the first power, right? And so there can't be any square roots in x's. There can't be any squares or cubes, because then that becomes a nonlinear equation. Okay, and so they have to be strictly linear. Okay, and so we can take any system of linear equations and turn it into a matrix form. And what that means basically is that we take all the coefficients in front of the unknown variables and kind of extract that into a matrix right here. Okay, and then everything that's left over, basically anything that's not multiplied by an unknown, we move that to the other side of the equation, and we call that the right hand side vector. Okay, and so, this form of the linear equations, I think, is the most convenient, just because, you can just literally just pluck out the coefficients and plop them in here. But sometimes if you're working with the system of equations, you might have to massage the equation, or kind of, work on it a bit in order to get it to this form. But once you get to this form, where each of the unknowns are kind of lined on top of each other, then pulling out the coefficients is very easy. Okay. Um, and so you might be asking, why would we want to do this? Why would we want to form the matrix form? Turns out that there's a lot of different methods out there that people have developed to take, a matrix set of equations like this and use it to solve for the unknowns. Okay, and so there's really, too many for me to count. It's crazy. And so, if you can get your system of equations in this form, you're in good shape. And in fact, MATLAB has a very simple way to solve this, and it's called the backslash operator. Okay, and so if you can define your system of linear equations as a coefficient matrix as well as a right-hand side vector, then you can define those as variables in MATLAB and use the backslash to solve it. Okay, and so here's an example of that. And so for this particular system of equations, where I've set up the equations such that all the unknowns are kind of lined up vertically on top of each other, and we extract out the coefficients. Okay, so here I've defined the left-hand side coefficient matrix as A, and then the right-hand side forcing vector I've defined as B. And then to solve for the values of x, all you have to do is just do A, your coefficient matrix, backslash B. Okay, and then MATLAB will automatically compute what the values of x are. So this first entry here is x1, the second entry is x2, this third one is x3. And it's as simple as that, right? And so this obviously is a lot more convenient than trying to solve the system by hand, right? And so the great thing about this is that, this backslash is very, very versatile. And so it's, not only is it convenient to solve small systems, which probably some of you are familiar with solving for, maybe your graphing calculators, but once you start to get to the much larger system where, you have like 10 equations, 100 equations, 10,000 equations, and even, I've seen systems with millions, even billions of equations, it's necessary to solve these with computational methods. Okay, and in fact, if you end up taking an elective class, either in computational heat transfer or finite elements, you'll learn that those methods just kind of naturally produce these large systems of equations, and it becomes basically necessary to solve these with some kind of program, either MATLAB or something else. Okay, and it's interesting because it seems like a fairly straightforward problem, but it's still a very, very hot topic of research. And so better ways to solve these very large linear systems I'd say is still, one of the top hotly contested research topics by, all the top labs around the world. And so, we're still trying to figure this out. But MATLAB provides, a pretty good solution for you to, solve most problems that you'll come across as a student.